Hello everybody, my name is Ray, this is Ayush and Peter, and together we built Flashdash. Flashdash is an interactive dashboard that allows users to visualize real-time graphical information for any dataset formatted in JSON. Using an external source, users can monitor company buzz on social media or an internal source to measure key company metrics. Our app can even be used for process monitoring of a chemical plant. Sensors gather relevant data, and once these data points are made available on an internal network, Flashdash is ready to work. Flashdash allows users to organize their data in a graphic representation in a quick and easy manner, so that the front end can be built in any way imaginable without any additional development on the back end. Now Peter is going to talk to you about how we handle incoming data.
Thank you, Ray. We decided that to differentiate ourselves from other dashboard templating apps, we would take in data through any URL that returns data in JSON format. We chose this because it allows us not to store data in our databases, it allows for up-to-the-minute data, and it is unique. Additionally, because the data that users are accessing is stored somewhere else, to get the most up-to-date version of the data, we need only to hit that URL again. The data accessed through the URL can contain other information that isn't relevant to the graphs. Instead of the users having to find data organized in a particular way for the graphs, Flashdash pre-parses the JSON and trims it to present only the information that the graphs could use. This gives the user more options and an easier time finding the API routes for our service. Now here is Ayush to tell you how we take our trimmed data and make graphs out of it.
Thanks, Peter. Once we have the meat of the data, we go through it and identify the data types associated with the keys that we receive. Once we've identified those data types, we show the users the available fields and the data types associated with each field. The user selects the fields that he wants to preview, and selectable graphs are rendered in the form itself. The user clicks what he wants to build, and it appears on his dashboard. Due to the flexibility NVD3 gives us, which we try to pass on to our users, it becomes really easy to create broken, ugly, or nonsensical graphs. Additionally, a user is not immediately aware of what the best graphical representation of his data will be. To overcome this issue, we did things, the way we did, by limiting user options, we were able to prevent broken graphs and create a better user experience. Now Peter's going to talk about time series.
Thank you, Ayush. One of the distinguishing features of Flashdash is that the data can be changed in real time rather than just displaying a static collection. The update interval can be matched to the frequency with which the data changes, from daily for sales figures to up to the second for the process control example. The update frequency is set when the graph is created. Once the chart is displayed, the user's browser process will ping the data source for updates without any load on the Flashdash server. An interesting technical issue that we faced was making sure that the ticking intervals that update the data are removed when they are no longer needed, such as when we remove a graph or change dashboards. Ultimately, we tied the interval objects to the DOM elements that they refreshed and used the scope's destroy event to ensure that the intervals were canceled when necessary, without having to program interval cancellation into each action that might require it. We are Flashdash. Thank you for listening, and visit our site at flashdash.info.